Welcome back, folks. We are continuing our discussion of complex fractions. We're working on simplifying complex fractions or rational expressions. And in the last video, we introduced the idea of the major fraction, which refers to this fraction bar, and then the minor fractions, which would be these smaller fractions nested inside. And remember that in some cases, it might be hard to tell what the major fraction bar is, and so we emphasize that somehow to our reader. Okay, so what I want to do is I want to find the LCD not of these collections of fractions, but just of the minor fractions. So for each of these minor fractions, I want to find the LCD, and here I'm fine with you just jumping to the answer, although in the last video I was more careful about breaking things down. The LCD here would be 12. That 12 takes into account all of the factors of all of these numbers. Notice that's 3 times 2 times 2. The number 4 is covered because it's 2 times 2. The number 2 is covered because it's just one of those factors, and as is the number 3. So there's our LCD. So the LCD for the next expression, again, I'm just talking about the minor fractions, would be then x plus 3 times x minus 1. And then here, the LCD, you could split some hairs on this if you disagree with me. There's other ways to think about it. But for right now, we'll just go ahead and say the LCD is the cotangent of x times the tangent of x. Okay. So there are two different strategies for how to simplify complex fractions. And usually students prefer one method, which I'm not going to show here, and I prefer another one. The reason why I prefer the other method is even though your earlier method may work well for numerical problems like this one, and it may even work for some more complicated expressions involving x, say like this one or this one, eventually in your math career you will want to know this second method. So I'm going to ask you to, even if you have a way that you like to simplify complex fractions, for this video and this pre-work, I'd like you to use this method. So the method that I teach is to multiply the major fractions by the LCD of the minor fractions with the goal of clearing out the minor fractions. So let's go ahead and give that a shot here. I'm going to copy down the question. We've got 1 plus a half divided by 2/3 plus 1/4. And up above here for this same fraction, we identified the LCD to be of the minor fractions to be 12. So I'm going to multiply the major fraction by 12 divided by 12. Now, this first time through, I'm going to show all the work for what we do here. So I'm going to show the work of distributing this 12 to each of these terms and simplifying, but ordinarily you would skip this step. You would do this step in your head, and you know that it's going to work out nicely because you're using the LCD. So when I go ahead and distribute, and we need to do the same to the denominator, when I go ahead and distribute 12 to both of those terms, we end up with 1 times 12 plus 1/2 times 12, all divided by 2/3 times 12. Looks like I missed a fraction bar there. Plus 1/4 times 12. So ordinarily, I would not do this step. I would not write out this step. I would just do this step in my head. And that's why sometimes students don't prefer this method for simplifying complex fractions, because it's harder to follow somebody else's work. If they're not showing this step and instead they're just going to the next one, I could see why that might be difficult. But ordinarily, you'll just go ahead and skip this step. So I'm distributing 12 to the first term here. That's just going to give me 12. But look, when I distribute this 12 to the second term in the numerator of the major fraction, I get 1/2 times 12, and that's guaranteed to clean up nicely. Not always when I multiply a whole number times a fraction do I again get a whole number, but I'm guaranteed that when I take 12 times a half, I'm guaranteed to get a nice number. Why? I want you to pause the video, think for that. It's not a question to write down, but I want you to pause the video and think for just a second. How come I'm guaranteed that when I take 1/2 times 12, it's going to clean up nicely? So if I were multiplying 13 times 1/2, that's not going to clean up nicely. But notice that we got the number 12 by taking the LCD of all of these minor fractions, and so 12 has built into it a factor of 2, and when I multiply 12 to 1/2, the factors of 2 will cancel, and I'll just be left with 6. And so that's the reason why this will always clean up nicely. Similarly, I got the number 12 here by building it from the LCD factor, so when I distribute this 12 to this 2/3, I'll get 3 goes into 12 4 times, and that remaining factor of 4 times 2 will give me 8 for that second term there. Now again, if I did that too quickly, you could go ahead and just compute this the way you normally compute products of fractions, and you'll see that you get the answer 8. But what you really want to do is you want to trust that when you wrote out the LCD, that you would have factors that cancel out appropriately. So likewise, when I take this 12 and multiply it to 1/4, well, 12 has a 4 factor in it, and so the 4 factors, this factor of 4 here in the denominator of this minor fraction, will cancel or divide out with this factor of 4 in the LCD that I'm multiplying it by, leaving me with just the factor of 3 that's in this expression. So I get 1 times 3, or 3, and we can now clean this up as 18 over 11. We check to see if that simplifies further, and it does not. So what I'd like you to do is I'd like you to pause the video and work the next 2 problems to really get this process down. In this one I give a very detailed solution, and in this one I just give you the answer, although I give you a little bit of a hint, I think, somewhere. So folks, you've paused the video, you've tried these 2 questions, and I will see you in the next video. Thank you.